Hey guys, we're going to start chapter 12 today. It's going to be on circles. So we've talked a little bit about circles before. I've got a few definitions just to review to make sure that you remember. Remember, a circle, the definition of a circle is it's in a plane. It's the set of all points equidistant from a given point called the center. The diameter goes from edge to edge through the center. A radius goes from center to edge. Congruent circles would have a congruent radius or radii. A central angle is an angle that goes from side of the circle to vertex to side of the circle. A circle is named by its center point, so this would be circle P. And then remember we talked about arcs as well. A minor arc is less than half of the circle. A semicircle is exactly half the circle, and a major arc is bigger than half of the circle. You name minor arcs by 2 points. You name major arcs with the 3 points. Arc measure is another thing we talked about. Arc measure, remember the measure of an arc is the same as its central angle. So if a central angle is 50 degrees, the measure of its arc would also be 50 degrees. And if that's 50 degrees, the rest would be 310 degrees because all of the central angles add up to 360 in a circle. So that means arc TQR would have a central angle of 310 degrees. And if it's a semicircle, it would have 180 degrees because it's half of the 360. Remember, if you have circles kind of overlapping with the same center point, it would look like this. It's kind of a bullseye looking thing. Those are called concentric circles. And then another thing we talked about was arc length, and arc length is a fraction of the circle circumference. So remember, it's the measure of the central angle divided by 360 times the circumference of the circle. So there's a good review. So we'll just see. We'll have a couple of review questions here. It says, answer each question about circle O. Its radius is 18. Okay, so it says find the measure of arc BE. So the measure, remember measure is just the same as central angle. So from B to E, we're just missing one of those angles, and then we can just add all of those together. So I see here that this is a 90-degree angle. This is also a diameter here. Segment DA is a diameter. So that means there's a semicircle in there. So I've got 90 and 30, that's 120 of the 180 if that's a half circle. So that would have to be 60 degrees, the missing one there. So then to get arc BE, we just have to add those together. 35, 60, and 30 would make 125. And remember the arc measure is the same as the central angle. Okay, next one is arc AED, so that goes from A to E to D. Well, that one's pretty obvious. It's the half circle, so it's 180. The last one says the length of arc DEF. I don't know why I put 3 letters on there because that's a minor arc, but that's okay. So length, remember, is different than measure. Length is circumference times, well, I guess I usually do central angle over 360 times circumference. So first thing we need to know is what's the central angle of arc DEF? Well, 90 and 30 is 120. So that's 120 out of 360 times the circumference, which is pi times diameter. If the radius is 18, the diameter would be 36 pi. 120 over 360 reduces to 1/3, and 1/3 of 36 is 12 pi. We'll just leave it in terms of pi. Okay, so hopefully you remember those things. The next part is a little bit newer. It's talking about the properties of tangents. So what is a tangent? Now it's not those trig functions that we did before. When we're talking about circles, tangent is different. A tangent is a line that intersects a circle at exactly one point. That point where the circle and the tangent intersect is called the point of tangency. So here's an example of a tangent. Segment or line AB is a tangent because it intersects this circle at exactly 1 point. And that point is the point of tangent C. Now there is a interesting correlation between tangents. If you have a tangent of a circle and you go from radius to that point of tangent C, it will always be a right angle. So it's always going to be a right angle. So that's kind of interesting. So we can use those properties to find some missing things. It says lines that appear to be tangents are. So anything that looks like it is a tangent is a tangent. And then we're just finding the values of x here. So since this is a LM is a tangent and I draw a radius to the point of tangency, this would be a right angle. That would also be a right angle for the same reason. So since this is a quadrilateral, we know that the 4 angles together have to add up to equal 360 because that's any quadrilateral is 360 degrees. 90 and 90 is 180. 180 and 117 is 297. So 297 plus x has to be 360. If you subtract from 360, you get x to be 63. Okay. On the next one, I've got my tangent. They already told us the right angle is right there. So look at what we have. We've got a right triangle, really. So we can use the Pythagorean theorem to find x on a right triangle. So that is a squared plus b squared equals c squared. Remember, a and b have to be the legs, c has to be the hypotenuse. So the leg is x, another leg is 12, and then the hypotenuse is, sadly, x plus 8 squared. So that one's going to have to be FOILed out, no big deal. X plus 8 times x plus 8. So that's going to be x squared plus 144 equals x times x is x squared. X times 8 is 8x. 8 times x is 8x, so I've got 16 x's. And then 8 times 8 is 64. Which is nice, because if I subtract x squared from both sides of the equation, they both cancel out. So that's no big deal. So I would have 16x. I'm going to go ahead and subtract 64 as well. 16x equals 80. And divide by 16, and x would equal 5. And you've got your solution. All right, let's see what's on the back here. Next page, I mean. Okay. Number 3 says, is segment ML tangent to circle N at point L? So how do we test that? Well, if it's a tangent, what would it have to have? It would have to have a right angle. So we want to know, is that a right angle? So how do we test that? Well, it's a triangle, so we test the Pythagorean theorem. Is 7 squared plus 24 squared, is that equal to 25 squared? Okay, so 7 squared is 49. 24 squared, I don't know that one. I'm going to get my calculator. 24 squared is 576. And 25 squared is 625. I do know that one. And then 49 plus 576 is 625. So since these two match, yes, it would be tangent. Okay. Now, 2 circles. We're going to be talking about 2 circles now. 2 circles in a plane can share a tangent line. Common tangents are lines that are tangent to 2 or more, or to more than 1 circle. So there are multiple possibilities for intersections of 2 circles and their common tangents. So notice, if we have 2 overlapping circles that intersect each other, 2 intersecting circles, there are 2 possible tangents that we could draw. If you have 2 circles that intersect at exactly 1 point, there are 3 possible tangents. If you have 2 overlapping circles where they intersect on one side and the centers are not the same, you have 1 common tangent. If you have concentric circles, there are no tangents. And if you have circles that don't intersect at all, and they're inside of each other. Again, no tangents. But if you have circles that don't intersect at all and they're not overlapping, there are 4 possible tangents. So that's interesting. So why did we talk about that? Well, because if you have a tangent, 2 tangents really, from one single point outside of a circle, then the distance from the point to the point of tangency of each is going to be equal. So if you have a point outside of a circle, you draw the 2 tangents. Segment BA would be equal to segment BC in this. So we'll use that property on a couple more examples. So here we have that exact scenario. We have a point outside of a circle. We drew 2 tangents. So we know that these 2 segments are congruent to each other. So we're able to say that x squared equals 10x minus 9. Now that kind of, remember, a squared type of problem, you have to solve by either factoring or using the quadratic formula, whatever you combine, or whatever is convenient. This one's nice and easy to factor. So remember, you set the equation equal to 0. That's your first step. So we subtracted 10x, and then I added 9 to get it to the left side of the equation. And it factors very easily. Remember, if your third sign is positive, you adopt the sign of the second for both. So it's going to be x minus something and x minus something else. What are the factors of 9 that add to 10? Well, your options are 1 times 9 or 3 times 3. Which of those add to 10? Clearly 1 times 9. You set each factor individually equal to 0, and your 2 solutions are 1 works and 9 also works. So you actually get 2 solutions on this one. So 1 or 9 would work for the length of that. Okay. Again, here, these are tangents. Find the perimeter of triangle ABC. This is very, very simple. Remember, if you have a point outside of a circle, then these 2 pieces are congruent. So if that one's 15 up there, this one's 15 down there. If this piece right here is 8, that piece down there is 8. If this piece is 10, this piece is 10. So we've got 10 and 10 is 20, 15 and 15 is 30, 8 and 8 is 16. Put those together, 66 centimeters is the perimeter. So that should cover all the types of problems you'll see on MyMathLab. Let me know if you need any help with any of the other things. And good luck. We'll talk to you soon. Have a great, great day.